good afternoon, good evening. You're watching Makoge.com. We're in the substation right now, and basically in the LV room, low voltage room, where we have low voltage panels as well as other equipment panels that are installed. Um, there's this one um, panel which I want us to discuss about, which is very important as far as installation of equipment panels, etc., in a substation is concerned. Basically, have you ever wondered why the amount of power that you require or that is being delivered to you by the supply company, you're not able to consume all the amount of power that is being delivered to you? This is a question which majority of the people will be asking, and to find out exactly how to mitigate this problem. Basically, in installation works, when we are carrying out electrical installation works, we have different types of loads. We have resistive loads, capacitive loads, and inductive loads. So all these different loads, they have their different characteristics and how the current and voltage um, vary with each other. So we have some of these loads, the current will be leading the voltage, or the voltage will be leading the current, or probably the current and voltage might be in phase. So in a case where we have voltage and current in phase, we eventually have all the power that is leaving from the utility supply coming to our installation. We'll be able to utilize everything, which is very important. In that case, we'll have the angle between the voltage and current equal to zero, thereby reducing all the losses that we'll have along the line, which is very important. So in a case where we have in a case where we have inductive and capacitive components, in this case we'll have these are all reactive loads. We'll have reactive loads, which will be capacitive loads or inductive load. So these are the loads that will cause us not to be able to utilize all the power that is leaving from the utility supply company. So how do we mitigate this? I'll take us now to an amazing component which is installed in the substation, which normally we'll find it which is used to um, mitigate this issue by reducing what we call the power factor, which I'm going to explain. Power factor is a cosine difference between current and voltage. So, or the ratio between the ratio between the active power to the apparent power. So, while we keep reducing the angle the active power and between the active power and the apparent power, will thereby reducing the angle, which therefore will increase the Coase field, which is the power factor, which is our major goal. So by so doing, we'll be able to utilize all the amount of power that is leaving from the supply authority company or the utility company. So I'll give you a quick view of this panel which is installed in the substation. As you can see, this is the LV panel which is installed already, and then we have a capacitor bank, which is the amazing component when it comes to power factor improvement. Like I did mention, power factor is a cosine difference between voltage and current. So this amazing component, which is the capacitor bank, in this case, this is rated 350 kilovolt ampere reactive. So this capacitor bank will be able to reduce the angle between the active power and the apparent power, thereby increasing the power factor, which is Coase field. I'll explain more in detail concerning the power factor correction, how to improve it, and the different power factors that we'll be having, and then how do we evaluate all of this, which is very important when it comes to power system stability, as well as improving power, power system in our homes as well as in industrial facilities, which is very important. Thank you very much. Until then, you're watching Makoge.com.